Okay, so our objective is to solve equations using inverse operations. Okay, we're going to define inverse operations simply as opposite operations. So, the first example of this is 4x minus 9 equals 17. Now my goal here is to separate and to isolate the x, or the variable, from the numbers. Okay, so I'm going to move all these numbers, I'm going to get rid of all these numbers from the side that the letter is on. In order to do that, I'm going to use the inverse operation, or opposite operation, of the number. This number is using subtraction, subtract 9. The opposite of that is addition. So I'm going to add 9. If I subtract 9 and add 9 at the same time, those cancel. Anything that I do on one side of my equation, or my equal sign, I have to do on the other in order to keep my equation balanced, so that these cancel, and I've got 17 plus 9, which is 26. And that equals what I have left over here. It's 4x. Now 4 is multiplied times x, so the opposite of multiplication is division. So I divide by 4 in order to cancel that out, which leaves me with x. Again, if I do something on one side of my equal sign, I have to do it on the other in order to keep it balanced. 26 divided by 4 is simply 6.5, 6.5. In order to check my answer, I take this x and I plug it right back in and work it out. If they equal each other, then I've got my answer. Two situations other than that I want to go over. Okay. If I've got 3x plus 4x plus 7 equals 7x plus 7. Now I'm going to take my like terms, meaning they have to have the same variable and the same exponent. Again, if you don't have an exponent, you assume that it has an exponent of 1. So these are like terms. I can combine 3x and 4x combined, just 7x, and my 7 is by itself. So I've got the exact same thing on both sides of the equal sign. Now what this means is my answer is all real numbers. Okay? So I can subtract 7x from 7x and get 0. I can subtract 7 from 7 and get 0. So that 0 equals 0. What this means is that no matter what number I plug in for x, it will work. If I plug in a 1, 7 times 1 is 7, plus 7 is 14. 7 times 1 is 7, plus 7 is 14. No matter what number you plug in there, it's always going to work. So any or all real numbers is your solution. Now another case of this would be if I end up with something like this. So something very similar, but just a little different. Now, again, trying to isolate my variable on one side of the equation, I take a positive 7x, subtract 7x from that, subtract 7x from here. They both cancel out because 7 minus 7 is 0. And I'm left with 7 equals 8. Well, now that doesn't make sense, so I know that my answer is no solution. Because no matter what number I plug in for x, it's never going to work. Okay, so the rule of thumb here is if my x's or my variables disappear completely and the numbers don't equal each other, they don't add up, then your answer is no solution. If I have the exact same thing on either side of the equal sign, then it's all real numbers. Your homework is page 94, numbers 1 through 15.